Welcome to Unit 4, Linear Equations and Inequalities. We're going to solve by inverse operations. So, filling in the blanks, we can see our outcome first. It says, I can model and solve problems using linear equations. So, linear equations form straight lines. That's what we're talking about. So, what is the opposite of addition? Anybody have a good idea here? Subtraction. Perfect. So, addition and subtraction are inverse. What's another word for inverse? Another word for inverse. Opposite. Perfect. So let's write opposite, just in case we forget sometime and you're reading your notes later. So they are opposite operations. So I want an opposite operation for multiplication. What would that be? Division. Perfect. Multiplication and division are inverse operations. So, inverse operations, they undo or reverse each other's results. So we're going to be talking about isolating the variable. Isolating the variable is the ultimate goal that we have when we solve a linear equation. We call this ITV. Okay? ITV. Isolate the variable. So we need to isolate the variable. So any variable. So it's talking about inverse operations, and we're going to use them to determine what we're applied to the variable. So we're going to do what we call wrapping a present, and then we're going to unwrap the present. Okay? So we're going to build the equation, we're going to find out what happened to the variable, and then we're going to undo it. And you're going to actually understand, and you're going to realize that creating an equation actually helps you solve the equation. So let's take a couple examples. Our first example, we have a one-step operation. These are all one-step operations. So how do we get x by himself? Any ideas how we can get the variable all by itself? We want to isolate it. Brackets? Well, we don't need brackets in this case. We need to move something across the equals sign. So we need to do something that we did in Unit 3 where we had opposite colors. When we have opposite tiles, they cancel, remember? So if I've got opposite tiles that are canceling, what am I actually creating? A zero pair. So we want to make a zero pair to move across the equal sign. So you need to make a zero pair. So we need to move the positive 2.4 over to the right-hand side. How would we possibly move that positive 2.4 all the way over with that 6.5? This is where we do our opposite operations. What can we do there, sir? Yeah?
Negative.
That's exactly right. The opposite of our positive sign here is to subtract 2.4. So we're going to subtract 2.4 from both sides. What this has done is it's created our zero pair. So here's our zero pair. It completely disappears now. So this is gone. You can wipe it off. We are going to get a result of x equals, and now we subtract 4.1. And now we need to check our solution. Verify means check our solution to make sure that it works. Well, what does it mean by check to see if it works? Well, whenever we've got an equation, it's like a balance beam. We have to make sure one side is going to be equal to the other side, which means it has to be completely balanced. If it's going to be completely balanced, it has to have the identical amount on both sides. So, if I want this to have the identical amount on both sides, we're trying to say, does the left side equal the right side? That's what we're trying to figure out. LS equals RS. So we draw a line down the equal sign, and now we substitute the number we solved for x. So we solved 4.1. So where the x is, I'm going to put 4.1 because that's the answer we got. And now I'm going to write the rest of the equation, plus 2.4. I'm going to add them together, and I'm going to get 6.5. Now, my right-hand side says I'm at 6.5. Does my left side equal my right side? It sure does. So, because these guys are equal, we can now say that this is a true solution. Sometimes our left side doesn't equal our right side. You're going to deal with questions like that in grades 10, 11, and 12, okay? For now, we're going to deal with questions where our left side does equal our right side, okay? So again, we used an opposite operation. We brought our 2.4 across the equal sign by making a zero pair, and then we checked our solution to see if the left side equals the right side. Now we're going to try example 2. Example 2 is set up a little bit differently. Who remembers what this divide line or fraction line does? Well, I just told you, my goodness. It means divide. Okay? So that fraction line means divide. And we're supposed to be doing the opposite operations. So what is an opposite operation to divide? Multiply. Perfect. So that means we're going to multiply both sides, because we have to do it to both sides, by the same number, by the number on that bottom. So we're going to take and multiply both sides by that 4. Well, what is 4 divided by 4? 1. Well, that's what's going to happen. 4 divides by 4, and they cancel. And now I'm going to get a hidden 1 in front of my x. And that's what we want. Whenever we isolate our variable, we want a hidden positive 1 in front of our variable. Okay? Remember, only hidden positive 1s can hide. So we want our hidden positive 1, and now that's going to equal how big? 6. Okay? So then we get x equals 6. Now we're going to go over and check and make sure it works. So we're going to draw a line down our equal sign. We're going to put the x number we found where it belongs in the equation. So we have 6 on top, and we've got the 4 on the bottom. We found the 6 from what we solved for x. Okay, so we're putting it where x goes. Okay? Now we're going to divide the numbers. And when we divide them, we're going to get 1.5. So that means the right side is also 1.5. So we have a left side equaling our right side. We always have to prove that the left side equals the right side. So again, what did we do? We substituted our answer for x. So we substituted the answer for x. That's our red number there. So we found our x on the left-hand side when we solved the question here. We solved this 6. So then we put our 6 in the equation where the x was, and we solve it. Any questions so far? Now we're going to take a look at a couple extra questions. These ones are 2-step questions. They've got 2 different things involved. That means we've got to do 2 things to isolate our variable. So by opposite operations, the very first thing I need to do when we start solving equations is we use reverse BEDMAS. Okay, we use reverse BEDMAS to move terms across the equal sign. To move terms across the equal sign. Okay, so we use reverse BEDMAS. My one word's a little bit squiggly here. All right, so we use reverse BEDMAS to move our terms across the equal sign. So we're going to look at our reverse BEDMAS. We're going to say, okay, which are the bottom 2 letters? The bottom 2 letters are adding and subtracting. So anything that's being added and subtracted has to move across the equal sign first. So if we take a look, we've got a subtract sign. That means the number right after it has to move first. So I've got to move that 3.2 first. Okay? So we're going to take the 3.2 and we're going to add 3.2 Who can tell me why we're going to add 3.2? That's exactly right. Opposite of subtracting. Okay, am I done? Can I just go 4.5 d equals 18, negative 18.5? What did I forget? Exactly. We have to do it to the other side as well. So we're going to have negative 15.3. And now we're going to divide our digits. Now, why would I say divide? Who can tell me why I said divide? That's right. There's a hidden time sign. When they're sitting side by side, they're being multiplied. So we're going to do the opposite, and we're going to divide the number sitting beside the variable. So we're going to divide by 4.5 on both sides. Divide by 4.5. Okay, everybody get your calculators out and start dividing. So we are going to check our solution. We get d is equal to negative 3.4. And again, now we have to check our solution. So we're going to write our equation, 4.5. We're going to put a bracket where we need to insert our substitution for our variable. We draw a line down the equal sign so that we can make sure and check to see if it is equal. Okay. Our answer is negative 3.4. We're sticking negative 3.4 in. Okay, any questions on where we substitute? We're putting it in where the d value is. That's called substitution. Now we're going to multiply the two digits together. Who knows your answer? What are you getting? Negative.
Excuse the interruption, please. There's been a problem with our PLT sign-up system. It has wiped everyone's responses from today.
Okay, so we're continuing, and when we add these up, we're going to get negative 18.5, which is equal to the right-hand side of negative 18.5. So the left side does equal the right side, so again, we have a true solution. We are going to move it up to the bottom, and again, we're going to see two things happen to our variable. So we have something that's joined by a plus sign, something that's joined by a divide sign. So again, we're going to use reverse BEDMAS, and the A and the S have to come first, adding and subtracting, to move across the equal sign. That means I'm going to take my 3 and move it first. So how do I move a positive 3 across the equal sign? That's right, and make it a negative to do a zero pair. Now you could also think of the equal sign as an electric fence. The minute a number crosses the equal sign, if it's being added or subtracted, and this only works if it's being added or subtracted. It's like an electric fence. It zaps it. And then when it zaps it, it switches the sign. Okay? So, we got zapped here, switch the sign to a subtract. So we have A over 4 equals 4.2. We have to subtract those. Whenever I do to one side, I must do to the other. Our last step, that A is being divided. Okay? So to continue and isolate our variable, we're going to multiply both sides by 4. That removes the 4, and we get our hidden 1 in front of our A value. So now we get 4 times 4.2 to give us 16.8. So that's our final solution. Now we're going to put 16.8 in where the A number is up on our verify side. So we're going to check our solution. So we're going to put 16.8 over 4 plus 3 should equal our 7.2. So our next step, we always have to solve the fraction. So we're going to solve our fraction, and that's going to give us 4.2. Plus 3 is going to give us our 7.2. So that means we've got our left side equal to our right side. 7.2 equals 7.2. So now we're going to use the box strategy. The box strategy to solve equations. What we do is we always start with 3 basic segments in our boxes. The first box is always the variable. So we're going to put our variable in the first box. We have an x. Now we're going to put an equal sign on the far right between the boxes. And we need to put an equal sign on the bottom, on the left as well, below our x. Okay? So we have two equal signs. Now on the where we see the right-hand side, if we've only got one digit on the right-hand side, this guy goes to the bottom right box. Okay? So his box is on the bottom right. You put a 20 there. Okay? So those are the first two things we can always put in there first. So you can always put your variable, the equal signs, and the answers. Now what we've got to do is create the equation. We find out what happened to the variable. And when we build the equation, we use BEDMAS. So whatever's sitting beside the variable or underneath the variable has to be done first. Okay? And it's always beside, then under. Okay? Kind of like top bunk and bottom bunk of a bunk bed. So, let's take a look. What is the first thing that happened to x? If I were to look at x, what is the first thing that had happened to him? He's sitting beside a number. And sitting beside a number means he was multiplied by a number. So x multiplied by what number? What number do you see sitting there? A negative 3. That's going to give us our negative 3x. Okay? So we're building our equation. Now, this box right here should be quite large because it's actually going to be the entire left side of the equation. So this is going to be the left side of the equation. Okay? So, x was multiplied by negative 3. Then what happened? What do we see sitting next to the negative 3 and the x? A plus 5. So they added 5. So we're going to put plus 5. So now we've got negative 3x plus 5. There's our equation. The next step, I'll let you get caught up. So what we do on the bottom, we're going to take a look down here, and we're going to do exactly the opposite. So what is the opposite of adding 5? Subtracting 5. Good. So now we're going to take 20, and we're going to subtract the 5. We're going to get 50. Okay? Now we're going to do the opposite of what's on the other arrow. What's the opposite of timesing by negative 3? Dividing by negative 3. So we're going to divide by negative 3. So now we're going to get a negative 5 for an answer. Now, our final answer can always be written right there. There's your final answer. X equals negative 5.
That's simple.
Okay? So now we're going to write, we have to take it out of the box, and we say this solution for this equation, we would say x equals negative 5. And we always box or circle our final solutions. Okay? So make sure you box and your final solution. Our second example. All right, we can insert a few things in our boxes. We can put our x, our equal signs, and the right-hand side of the equation is the 19. Now we have to build the equation. We have to say what happened to x. So remember, what happened to x is the very first thing when he's being times or divided. So what is the first thing that happened to our x? Beautiful. Multiplied by a negative 2. So we get our negative 2x. Perfect. What is the next thing that happened to x? Right, they subtracted 7. So now we're going to have our entire equation written right here. Negative 2x subtract 7 equals our negative 19. Now we're going to go down and do the opposites. So we're going to go down here, and what's the opposite of subtracting 7? Positive. We're going to add 7. So that's going to give us a 26. Okay, so we have to do the opposite of what was on top. So opposite of subtracting is adding 7. Now we're going to do the opposite of multiplying by a negative 2. What's the opposite? Dividing by a negative 2. So we're going to take our 26 and divide by a negative. So positive divided by a negative is a negative 13. And again, we're going to take our answer out of the box. X equals negative 13. and then box or circle your final answer. So again, we can find our final answer vertically, and then we pull it out of the box. Okay? So we need to figure out how many boxes we need to go across the top and how many boxes we need to go across the bottom. Okay, how do we figure out how many boxes we have? We need to count how many things are going on with X. So first of all, X gets a box, so that's one box. Then you need to have a box where you have something multiplied to the X. So you need a box for the multiplying, and you need a box for the adding of the 7. So you need 3 boxes, that's how you decide. So count how many objects you have on the left. You've got 1, 2, 3, which is why you've got 3 boxes. So we have X first, and we have our equal sign. We can stick our negative 11 in. Okay, so we always start, and now we can put our arrows up. Okay, so we have some arrows going on. So we say, what is the first thing that happened to X? He was times by a positive 2. So we get 2x. Then what happened to our x? Well, we had a hidden plus sign out there, so it's actually being added to the 2. So we have plusing 7. So this could be written 2x plus 7 or 7 plus 2x because they're both positive. So whichever way you want to write it, 2x plus 7 or the 7 could go first, they're both positive. Now we're going to undo what we just did. So we added 7, we're going to subtract 7. And that's going to give us a negative 18. Undoing the timesing by 2, we're going to divide by 2. A negative divided by a positive, it's going to give us a negative 9. So we have our solution. X equals negative 9. We're going to put it in a box. We have our final solution. And we know our final solution is always vertical. Okay? Check your work, make sure it matches what we did. Now we're going to do the second question. So we start with our y, when we have our equal signs. And we can put in our 7. So the first thing that happened to y was he was divided by 4. So we're going to put divide by 4 to have y on top of the 4. That's how we get the y on top of 4. Then what happened to our y was they subtracted 3. So we're going to get y on top of 4 subtracting 3. There's our full equation. Now we're at the point where we're going to work backwards. So instead of subtracting 3, we're going to add 3. That's going to give me 10. And over here we divided by 4. We're going to times by 4 and get an answer of 40. So in this case, our final solution, y equals 40. We're going to take it out. Y equals 40. Final solution. This concludes lesson 1. Woo!